Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the points at which prime of f at x is equal to 0 for these functions. So let's start with the function on the left side. So we have to find the derivative of this function and then set the derivative equal to 0 and solve for x. So now as you can see that this function is a polynomial function. So the prime of f at x equals, so we'll have to find the derivative of these three terms in this function. So the first term is x cubed, and for that we'll have to use the power rule of derivatives. So as per the power rule, the exponent 3 will come to the front and we'll subtract 1 from the exponent. So we get 3 minus 1. Now in the second term, 6 is the coefficient, so it will stay as it is. And now we'll use power rule for x squared. So we'll move the exponent to the front of the term and we'll subtract 1 from the exponent. Now the third term is a constant, so its derivative is equal to 0. Now we'll set the left side equal to 0 and then solve for x. So we can simplify this equation. So the first term becomes 3x squared, and in the second term we multiply 6 and 2 and we get 12, and then x exponent 1, but we don't write 1 as an exponent, and the 0 goes away. So now we have to solve this equation. Now this is a polynomial equation, so the first thing we can do here is factor. So we can use common factoring. So we can factor out 3x, and in the parentheses we get x plus 4. So now we get two cases. So the first case is 3x equals 0, and now we can isolate x by dividing both sides by 3. So the 3's on the left side cancel each other out. So we get x equals 0 because 0 divided by 3 is equal to 0. And now in the second case, we set the other factor equal to 0. So x plus 4 equals 0. And now we can isolate x by subtracting 4 from both sides. So the 4's on the left side will cancel each other out and we get x equals negative 4. So we got two x values at which the derivative is equal to 0. But in the problem we have to determine the points. That means the ordered pairs. So that means we also need the y values for these two x values. So for that, we'll sub in these x values one by one in the given function and find the function value. So let's start with x equals 0. So we'll sub in x as 0 in the given function. So f at 0 will be equal to 0 cubed plus 6 times 0 squared plus 1. Now we can evaluate this expression. So the first two terms go away because they're just 0 and 0, and we are left with just 1 because 6 times 0 square will be just 6 times 0, which is equal to 0. So the first point we found where the derivative is equal to 0 is 0, 1. Now we have to do the same analysis for the second x value we found. So we'll sub in x as negative 4 in the given function. So f at negative 4 equals negative 4 exponent 3 plus 6 times negative 4 exponent 2 plus 1. So now we have to evaluate this expression. So f at negative 4 equals, so negative 4 exponent 3 will be a negative number, so it will be negative 64. And then negative 4 square is equal to positive 16. So we'll do 6 times 16, which is equal to 96. And then plus 1. So now we can combine these numbers. So f at negative 4. So we'll do negative 64 plus 96 plus 1, which is equal to 33. So that means the second point at which the derivative is equal to 0 is negative 4, comma 33. So these are the 2 points at which the derivative is equal to 0 for the first function. So we are done with the first function. Now we can analyze the second function. Now the second function is given to us in the form of a radical term. Now before we find the derivative, we should change the radical into a rational exponent because that will make it easy to find its derivative. So we can rewrite this function as f at x equals then x squared plus 4 exponent 1 over 2. Now we can find its derivative, and for that we'll have to use chain rule because this function has an inner function x squared plus 4 and then the outer function is the exponential function with the exponent half. So prime of f at x is equal to, so we'll start with the derivative of the outer function, and for that we'll use the power rule. So we'll move the exponent to the front, so half times x squared plus 4, and then we'll subtract 1 from the exponent times the derivative of the inner function. So as per the power rule, the derivative of x squared is 2x, and then plus 0 because 4 is a constant. So now we can simplify this expression. So prime of f at x equals, now in the first part, so we can subtract the exponent. So half minus 1 is negative half. So we get x squared plus 4 exponent negative half times x plus 0 is just 2x. Now we can multiply the terms. So we can multiply the half by 2x. So we get the prime of f at x equals, so half times 2x will be just 2x over 2, and we can move this x squared plus 4 to the denominator to make the exponent positive. So we get x squared plus 4 exponent half. Now we can set the derivative equal to 0 because we have to find the x values at which the prime is equal to 0. And we can cancel out the 2's in the numerator and the denominator. So we are left with x over x squared plus 4 exponent half. Now we can cross multiply the denominator to solve this equation. So 0 times any term is equal to 0. So we get 0 equals x. So in this case, we got just one value for x, which is x equals 0. So now next, we have to find the y value. So we'll sub in x as 0 in the given function. So f at 0 equals square root of 0 squared plus 4. So f at 0, so 0 square is just 0 and 0 plus 4 is just 4, and square root of 4 is equal to 2. So for the second function, the derivative is equal to 0 at just one point, and that point is 0, comma 2. So this should be the final answer for the second function. So these are the steps you have to keep in mind to solve a problem like this one. So we have to find the derivative of the given functions. set them equal to 0, and then solve for x. And since we have to find the points, we also need the function values for those x values. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.